Atoms, tiny building blocks of matter, once thought to be indivisible, eternal spheres. But science, like curiosity, never stands still. In 1803, John Dalton proposed the first atomic theory. He imagined atoms as solid spheres, each element made of identical atoms, and different elements made of different ones. No internal structure. No surprises, just tiny, indestructible balls. But in 1897, J.J. Thomson shook things up. He discovered the electron, a negatively charged particle inside the atom. Suddenly, atoms weren't indivisible anymore. Thomson's Plum pudding model pictured electrons like raisins in a positively charged pudding. Sweet idea, but not quite accurate. Then came Ernest Rutherford. He fired tiny alpha particles at thin gold foil and made a surprising discovery. Most particles passed straight through, but a few bounced back. This led to the nuclear model. Atoms are mostly empty space, with a dense, positively charged nucleus at the centre. Electrons orbit around it, like planets around the Sun. Niels Bohr took things further. He discovered that electrons don't just float randomly. They orbit the nucleus in fixed energy levels, jumping between these levels by absorbing or releasing energy, like steps on a ladder. In 1932, James Chadwick added the final piece to the puzzle. He discovered the neutron, a neutral particle inside the nucleus. Neutrons help hold the nucleus together and explain isotopes, where the same element can have different numbers of neutrons. From Dalton's spheres to Bohr's shells, the atomic model evolved with evidence. That's the beauty of science. It grows, adapts, and reveals the unseen. And now it's your turn to explore the atom, because every discovery starts with a question.